Hey there, everybody. Welcome back. And today we are going to start talking about diazonium salt reactions. All right. Now, a little bit of wordplay. Di means two, and one of the really old pieces of nomenclature that still works its way into our modern naming systems is azo, or az in general, mean nitrogen. So what we're looking at here is something with two nitrogens that is a salt. All right, diazonium salt reactions are almost unparalleled in their usefulness in terms of what we can do with them in an organic reaction, especially aromatic rings. So to talk about it, let's first talk about making the diazonium. So to do that, we have to start with something like, or actually not something like, something that is nitrobenzene. For those of you who've been forgetting how to make that, it is benzene with a mixture of nitric and sulfuric acids. The next step we have to do is we turn that nitro into an aniline. There are a lot of ways that you can afford this reaction. The principal one that I like to talk to people about is tin and HCl. Now, it is almost sinfully easy for me to write down tin and HCl to reduce the nitro to an aniline. The fact of the matter is, it's not that easy of a reaction at all. It's very messy, there's a lot of byproducts, it's hard to purify, but as I've said before, on paper chemistry, it's just great. So now we take our aniline, and what we do is we react it with a mixture of hydrochloric acid and sodium nitrate. So the HCl and the NaNO2, note the difference. Sodium nitrite is NaNO2. Sodium nitrate is NaNO3. So what the difference of vowel make? Now these two things mixed and combined form nitrous acid. Now, nitrous acid in and of itself is unstable. Okay, how crazy unstable are we talking? Well, you have to generate it before you use it. You can't just buy a bottle of nitrous acid. It'll reduce fairly easily. The other thing about a diazonium salt reaction is they are carried out at 0 degrees centigrade. An ice bath is all you need. Now, ladies and gentlemen, doing this, what happens, and I'm not going to bother you for the mechanism because honestly I think it's kind of annoying, is this happens. This is the diazonium salt. There's a positive charge on that nitrogen, and the chloride is the counterion. The chloride doesn't do diddly. This, ladies and gentlemen, is where the magnificence of the diazonium salt reaction occurs. This also has to stay at 0 degrees C unless I say otherwise. So, for any upcoming quiz or exam or toolkit, I am going to assume, and you may assume, that it is at 0 degrees C, even if I don't specifically say so. I will let you know when this thing heats up, and because then it has some different reactions it can do. All right. But assume that it is 0 degrees C. If I don't write it down, you assume it's 0. If you don't write it down, I'll assume it's 0. All right. So let's see the wonder of this reaction. Honestly, ladies and gentlemen, this is my favorite reaction to teach, just because it has so damn much utility. So we are here. What we do is we can react this with copper chloride. Notice that is copper 1 chloride. And what we'll get is chlorobenzene. Now I can hear you out there thinking to yourselves, big deal. You know, it's why? We already have a way to chlorinate a ring. Well, fine. How about this one? Copper bromide. Well, I really don't care, Dr. Weigel. Why? Well, we're going to make bromobenzene, but we already know how to do that from the chlorination and the bromination of aromatic rings with benzene and aluminum trichloride. I should note really quick that on both of these, nitrogen gas is your byproduct. All right, smarty pants, I say, how about this? Potassium iodide. Then you make iodobenzene. Now, in years past, before I taught the iodine and nitric acid reaction, this got people excited, or at least less bored, because there wasn't another way to iodinate a ring. Well, now I teach the other way to iodinate a ring, and it's not that exciting. And so you're thinking, yawn, do something fun, Dr. Weigel, or we're going to stop paying attention. All right, fine, fuckers. How about this? HBF4 followed by heat. Well, now you make fluorobenzene. So shut up, Alex. We make fluorobenzene plus nitrogen. There's no other way you have right now of making fluorobenzene. Well, all right, what else can we do? Well, I'm kind of running out of room on this page, but we can also do this. H2O, acid, and heat. And guess what we can make? We can make a phenol. And there's no other way of making a phenol that you've got right now. Okay? So, what else can we do? Is there more? Yes, there is more. And it's a little lame that I have to go to the next page to do both of these. Sorry. So, now what we can do is we start with this benzene that has the diazonium salt. And what temperature do you assume that it's at, even if I don't say 0? That's right. And one of the things we can do is we can react it with copper cyanide. Copper 1 cyanide specifically. And what happens is we generate benzonitrile. And we don't have another way of doing that right now. All right, final one I'm going to show you from this is H3PO2. All right, notice the difference here, H3PO2. Now, the name of that stuff is hypophosphorus acid. I don't care that you ever be able to repeat that back to me in your lives. The point is H3PO4. H3PO2. And what this does is it turns the diazonium salt back into benzene. Now, normally I turn my nose up at these sorts of reactions because why would you take something interesting and replace it with a hydrogen? Well, there are reasons that we'll deal with in future videos why that can be useful. So real quick, I want to point out the reason I love this reaction is from one step, we go from benzene, to nitrobenzene, which we reduce using tin and HCl to aniline, all right? The aniline, we then react with nitrous acid, which can either be represented as HONO, HCl, NaNO2, 0, or you just write out nitrous acid. I'm cool either way. I assume 0. That way you don't think I'm hunting to take points away from you. And once you generate that nitrous acid, look at everything that you can possibly make. And I know about probably a quarter of you are going, wow, that is synthetically very useful. And the other quarter of you are going, holy fuck, this is a lot for me to memorize. Well, I tend to lean toward the former over the latter, but the latter isn't wrong either. So from nitrous acid, you can use copper 1 chloride to make chlorobenzene, copper 1 bromide to make bromobenzene, potassium iodide to make iodobenzene. All of those you can form from other ways. So let's talk about some unique ones. With HBF4 and heat, you generate fluorobenzene. This one is new. You don't have another way of doing this yet. With water, acid, usually from sulfuric acid, but I'm not too hidebound about it, and heat, you generate this from the diazonium salt to phenol. There's not another way you know of doing that. All right, what about the diazonium salt to benzonitrile? There are other ways you can make benzonitrile from benzene, but they're really drawn out and laborious. So trust me, this is your best bet. Finally, going from the diazonium salt using hypophosphorus acid, you can make benzene again. Now, the real utility of this last one, we're going to have to put a pin in it and have you trust me that it's out there and coming up. All right? So, anyway, tomorrow, later videos, we'll start covering activation, deactivation, making the reaction faster or slower, and then directing of groups. So, everybody, have a good day.